Hello, Python starters. Today we're going to talk a little bit about numbers and arithmetic operators in Python. So Python includes a variety of number formats to meet your needs, including whole numbers, fractional numbers, and complex numbers. So in Python, positive and negative whole numbers are represented as integers. Decimal numbers are represented using floating point to provide a good balance between range and precision. The term floating point refers to the fact that the number's decimal point can float in relation to the significant digits in the number. Now, Python also supports a wide variety of arithmetic operations for both integer and floating point numbers. You can see how these arithmetic operations work using idle interactive shell as a calculator almost. So let's do some examples of these. Let's jump into idle, and let's first talk about the Unary arithmetic operators. And so one of the simplest mathematical expressions is, the plus sign or positive indicator, or the negative or minus sign. So you can use these in front of a number to indicate that it's positive. So for example, plus 2 means positive 2. And you can also use the plus sign with a negative, so this is plus minus 6, keeps the minus 6 positive. And if you use the minus sign with a negative number, it becomes positive. So if I use the minus 7, that'll become positive 7. Okay, and then let's talk about addition. So you can sum two numbers using the addition operator. For example, 3 plus 5 yields 8. And you can store the results of mathematical expressions in Python variables to make it easier to keep track of things over time, especially as you have more complex mathematical operations and as values change over time. So for example, if you're using Python to track the number of passengers, you could say passenger count equals 3 plus 5, for example. And then when you type that variable name, again, it'll output the values stored in that. So in the previous example, both of those were whole numbers known as integers, so the result is an integer. You can also add with decimals known as floating point numbers. So if one of the terms is a floating point number, the result will be a floating point number. So consider this example. We're going to say pi equals 3 plus 0.14. If I type pi and look at that value, now you can see we have a floating point number. You can subtract two numbers using the subtraction operator. For example, 8 minus 3 is 5. And as you write applications in Python, consider the range of possible values that can result from your mathematical equations. For example, subtraction can yield a negative number. For example, if you subtract 8 from 3, you can get a negative value here, in this case, minus 5. Let's look at multiplication. So you can multiply two numbers using the star symbol above, shift 8, the multiplication operator. For example, 4 times 5 is 20. And it's pretty straightforward. And you can do division. So if we, for example, take two whole numbers here that result in a whole number, you'll notice that it yields 7.0. Now, why did that happen? Well, it actually returned a floating point number, and you'll see that decimal point. Why? And that's to display remainders as decimals. So even though this example didn't have a remainder, you want to be able to divide other numbers that do have remainders. For example, 2 divided by 3 is going to give you 0.6 repeating, or 11 divided by 3, for example, 3.6 repeating. Now let's talk about the modulo operator. It lets you see the remainder from a division operation. So for example, continuing that previous example, let's say you did 2 modulo, looks like a percentage sign, 3. That will return 2, since 2 cannot be divided equally into 3, so it's 0 remainder 2. Let's take a look at another example. 11 modulo 3 gives us 2. So 3, the result of that division is 3 remainder 2, and so it just returns the remainder. Now the power operator lets you raise a number to the power of the number on the left. So for example, if I put 3 using the power operator to, it looks like 2 multiplication signs and a 2, that's 3 squared, returns 9. Or if I do 3 raised to the power of 3 is 27. Now let's try an example. Let's create an application here. So let's go in here and create a new file. And I'm going to use a comment here to begin this one and say compound annual growth rate, or CAGR. So we're going to create a CAGR app here. I'm going to save this. Okay, so how do we compute the CAGR? CAGR equals the ending amount. So for example, I was looking at the number of Python developers. There's about 8.2 million currently. And if we look back at 2017, it looks like there were somewhere around 6.5 million based on data from /data. So we'll put that in there. And then we're going to raise this to the power of 1 divided by the number of years in the period. So this was over a 2-year period. And then we're going to subtract 1. And then we'll type print function CAGR. And we're going to save that. And then I'm going to go up here to the Run menu and choose Run Module. Okay, and so there is our result. So you can see that this is about 12.3%. So the average growth rate essentially for the number of Python developers each year is about 12% each year. So now let's take that result and let's estimate how many developers there will be 5 years from now. So, we'll call this Python developers in 5 years. And we'll take that CAGR and we'll basically just multiply that by the current number. So we'll take the 8.2 and then we will raise this to, we'll multiply this by the CAGR plus 1 and we're going to raise that by 5 years, and then just grab this variable here. We'll print that result. Okay, so we'll save that and use F5 to run that. Okay, so in 5 years' time, we should have about 14.7 million, so over 14.5 million Python developers in the world. So now that you understand the basics of numbers and arithmetic operations in Python, you have what you need to use Python as a calculator. So try your own math equations, get a better idea of how it works, understand and use arithmetic operations, because this is a foundational Python skill. And we're going to use this a lot going forward as we do some more interesting problem solving with Python and create some great applications. All right, thanks so much, and we will be back soon.